Please subscribe our channel Education Point and press bell icon to get notification of new educational videos.
Hello everyone, you are welcome to lecture number 86. Still I am on petroleum, and today I am going to discuss the inorganic and organic origin of petroleum. I have already given you the reaction of inorganic origin of petroleum, and then I will be discussing now the organic origin of petroleum. But before going to that discussion, it is very important for students to know all the notations what they are using in the reactions, so that they should understand the transfer of one electron or two electron, backward reaction, forward reaction, aromatic reaction, reversible reaction, irreversible reaction, what type of arrows are used to indicate those reactions. Only then we can understand. So I have already given all these arrows in detail. So let me show you. That is arrow marks, usually called, you can call this one, and then used for number one. This arrow, the number one, is used for a reversible reaction. A reversible reaction means the reactant and product. For example, if reactant is converted into product, again product can be converted into reactant. So such type of reaction is given by this half arrow and half arrow like this. It indicates that the reaction is reversible, and it also indicates that it is in equilibrium, the dynamic equilibrium of reactant and product. Number two, this arrow indicates that is irreversible reaction, means once reactant is formed into product, it cannot come back again to reactant, and it cannot be in dynamic equilibrium of reactant and product. That's why it is shown by this arrow. Then curve arrow. This curve arrow means to indicate movement of pair of electron. If this curve arrow is there, it means two electrons are transferred, maybe pi electron or some other lone pair of electrons. When two electrons or one pair of electron is transferred, it is shown by curved arrow. And this half fish hook arrow, it is called half curve arrow, and this curve arrow is called fish hook arrow. It indicates that there is transfer of only one electron when it is indicated by fish hook arrow like this. And when both sides are having tip, it means it is indicating the presence of resonance, means that structure can be represented by more than 1, 2, 3 resonating structure. When resonance is there, resonance hybrid, then this type of resonance, it is called resonance arrow. So it is indicated by resonance arrow. And to relate the contribution of different structures, then this your spiral zigzag type of arrow, not standardized. If any system, any reaction which is not standardized, then it is a spiral arrow is given, and this is called not standardized arrow, and as a pointer to indicate the bond. And if this type of arrow is there, number 8, in spectrum splitting, it shows that the bond is towards down, stereo bond, and it indicates the bond facing downward. This shows that bond is facing downward. So it is in continuation. That is how we can represent the reactions by showing the different type of arrows. So now number 9, if this type of conical type of arrow is there, it is called up stereo bond. It is upward. So what it indicates? Bond facing upward direction. If it is upward direction, then this type of will be there. When there is single line, when there is broken line, number 10, that broken line means it is delocalized single bond. If the single bond is delocalized, means the electrons are not fixed, then it is given by broken line. For example, your hydrogen bonding. hydrogen bonding is always shown by broken line. That is to show that it is delocalized, and that is delocalized bond. Number 11, if one line is there and below that line there is broken line, then it is delocalized double bond. It indicates that your double bond is there, and that in that double bond there is delocalization of electron. That is to indicate the double bond which is not confined. Means the electrons cannot be totally fixed in that double bond. That's why it is given with straight line and broken line. And then spring like number 12, you have seen here zigzag. It means it is a stereo bond, stereo type. That is undefined, where you cannot define, you cannot fix the position. That is the arrangement in space. If such is there, then we have to indicate like this: bond with unknown space arrangement. So it is like that. For example, if B is there and one is like this, one is like this, so if it is shown like this, BF3, so it means 1F is, that is to indicate bond facing, it is upward, and if it is with this type of showing, it means it is downward. So this is how we are showing all the bonds. Yes, in continuation, I have already told you about the two theories. One is, that is inorganic theory for the origin of petroleum, and second one is organic theory. And I have already given you the reaction, what it was given about the inorganic origin of petroleum. But in 1900, the theory came for organic origin on the basis of following facts, which is given here. So I am going to just explain to it. Origin of petroleum. Opinions are divided regarding the formation of petroleum. Any theory put forward to explain the origin of petroleum, we must explain the following important properties of petroleum. When we are going to discuss any theory, inorganic, organic, coordinate, whatever it is, we have to take in consideration the following properties of petroleum. The first is that the presence of chlorophyll. Presence of chlorophyll, it is green color, and from nature, it is only from plant origin we can get that natural green color, that is called chlorophyll, and chlorophyll is found in petroleum. The second, the presence of nitrogen and sulfur is also there. Then number third, that is optical activities. Make it optical activity, the optical activity. So these petroleum, they are optically active. They are capable of rotating the plane polarized light. Then number 4 is association with sodium chloride. They are associated with sodium chloride, and that is called brine. Then number 5 is presence of natural pigments. There are a lot of natural pigment there, and those natural pigment means natural coloring. That is called porphyrins. So there are presence of porphyrins. It shows that from nature, different type of flowers are there in plant, and they have different type of natural pigments like flavonoids, which are present in petroleum. Number 6, presence of red animal origin, that is related to RBC, red color, and that is called heme, HAEMIN. Heme is found in petroleum. So there are two scientists and chemists you can call. One scientist, according to Mendeleev, in 1876, it was Mendeleev who proposed, who gave his hypothesis, his findings, that petroleum is inorganic origin. It has nothing to do with organic. But he failed for all these points. Then in 1900, Engler, his name was Engler, in 1900, he gave his theory that no, it is not inorganic, but petroleum is organic origin. Thank you very much.